Hey guys, welcome back to a new day of LeetCode. It is 9:40 a.m. We'll try to do one before I go to church. Okay, so yesterday we finished construct binary tree with from a pre-order and an in-order traversal graph. This was quite hard, but I do think, and people do say that this is the most excuse me, people do say this is like such a, not such a, but a typical recursion question with binary trees. So I think it'd be good if we can restart, or if I can go through this again. I did it last night, so it should be fresh in my memory, but if I really go over the revision and I talk about how I did it, I think it would be very beneficial. So given two integer arrays, pre-order and in-order. So an integer array, where pre-order is a pre-order traversal of the binary tree. So we can see 3, 9, 20. So this is top to bottom, 3, 9, 20, 15, 7. And an in-order is the in-order traversal. So this starts from the very left node and then goes to the very right. So pre-order goes from root, left, and then right. So root, left, right, and then for 20, we can see it's root, left, and right. And then for in order, we can see that it goes left, root, and then right. So for us three, for the 9, 3, 20, it's here, it's 9, 3, 20. And for the 20, it's 15, 27. So we can use these characteristics to find out exactly where we are in the pre-order. Exactly where we are, exactly which node from the pre-order tree. So let's say we're at 9. We're processing 9. If we go through the in-order tree and we see 9, okay, then this must mean that this node here is the very left node of our subnode. So let's think about this 3, 9, 20 subnode. Let's say we process 3 first, right? 3, and then we go to the left, and then we do 9. Because we know the very left node comes first in the order tree, once we see 9, we see like, okay, this must be the end. So after that, we can start doing the right. But it's important to know that the in-order tree goes left, and then root, and then right. So if in the in-order tree we go into the grandparents. So I guess we're trying to make a node here. If we go to the grandparents node, because it goes left, root, the in-order tree goes left and then root, right? Yeah, left, root, right. If we hit the root, that must mean that this is the end. Yeah, for a subtree such as 7. If we actually run into the parents, if we run into the parents node, we must understand. Well, if we run into the parents node, we must understand that this is the very right element of our subtree. Does that make sense? Yeah. So it goes 9. So we know if we hit the exact parents, we know this goes left and then root, right? So if it's a 9 value, that means this node, this like the parent node, this 9 is the end of its subtree. But if we hit the root node, we know that everything on the right of this in-order tree must be on the right side of this root node, right? So there's no way that there's more nodes going to be written here because everything after this root node belongs to the right side of a normal tree. So first we need to make pre-order and in-order a global variable, and then we're gonna keep the index of our pre and in-order. Is that a DFS? Is it a DFS? Yeah, it's a DFS. DFS, and then we're gonna be taking in a limit. So up here we'll be returning the DFS with passing through a float. Okay. So first things first. If our pre-index is bigger or equal to the length, this means we have gone through the entire array, so we can simply return. But if self.inOrder self.inIDX is equal to the limit, we can add one to our then return none. Okay, this row left case means, yeah, so if we hit the 9, if we're doing 9 and we get the 9, we're going to return none. you'll see later, but for the limit, if we pass 3, then we return none. Then we're going to first create our tree node with the value of self.pre_idx. And then the node to the left is going to be self.dfs. Then we're actually going to pass down the node value for this. And for our right, we're going to pass down the parent, because we said for our right, we're going to be checking the parent's value. Not value, but we're going to pass down the limit. And then we're going to return the node for this. Whoops. Oops, I don't want to make indices with the index, but we want the actual values. So it's actually ending one early. There we go. I should have used just this and -1, or both this and like this. But yeah, there we go. Cool.